After retiring Bertha, the world's largest tunnel boring machine, the United States secretly began developing an even larger TBM to create a revolutionary transportation structure. Hidden from international media, the project proceeded underground. Citizens only saw clouds of dust and heard loud noises. After extensive investigation, the identity of America's mysterious giant TBM has been revealed. Just how massive is this machine? Join us in this special episode as we unveil the American secret capable of drilling through a mountain in a day. Taking on a mega project. To speed up their national advancement in construction and structural development, the United States facilitated a 57.5-foot diameter boring machine built specifically for the Washington State Department of Transportation's Alaskan Way Viaduct Replacement Tunnel Project in Seattle, Washington, United States. The machine was assembled in Osaka, Japan. It was launched on July 2013, a perfect time to show the world the United States transportation advancements and fight the potential of an earthquake. At the time of manufacturing, the $80 million machine was the world's largest earth pressure balance tunnel boring machine with some sophistication. Bertha had a special pre-programmed melody that played for workers inside the machine and those monitoring the tunnel borer. But Bertha's journey did not start in 2013 like the world assumed. It was a vision coined as far back as 2001. In February, 12 years before the launch of Bertha, the rural community of Nisqually, Washington, was the epicenter of a magnitude 6.8 earthquake, now known as the Ash Wednesday earthquake, that rocked the region. In the city of Seattle, about 400 people were injured in the quake, and one person died of a heart attack, but the area's infrastructure was affected the most. Further inspections of the region showed that most of the infrastructure would not take another tremor. The city quickly organized a program to restructure the public infrastructure, and they did all except one, the Alaskan Way Viaduct. While the viaduct was dangerous to repair, the engineers knew that it would not take another earthquake, so they had to replace it. After years of deliberations, they decided that the viaduct would be demolished, and the north and south stretches of State Route 99 would be reconnected by a $3.1 billion tunnel that would run away from the waterfront, the line of the viaduct, and the Battery Street tunnel that linked the viaduct and the north end of the roadway in Seattle. The tunnel would run under the city center at 200 feet to avoid a forest of pilings, cables, and pipes from some 160 buildings above. It was a big project, and the engineer needed one major tool: Bertha, the world's biggest tunnel boring machine. After manufacturing Bertha in Japan, it was disassembled for easy movement and shipped to Seattle before being put back together. It was too big to cross the sea. The gigantic machine consisted of a 2,000-ton cutter head, a slurry pipe, a shield, a control room, and a trailing gear. On July 30, 2013, the assigned engineers got to work with Bertha under the eyes and cameras of the international media. The tunnel boring machine started digging into a cement plug with a view of coming out on the other side of the city center in 14 months. While it looked like a normal digging process from the outside, Bertha had some dangerous things coming that were not rocks and clay. The fall of Bertha. Although the entire route for the megatunnel construction was studied and many test samples were drilled, the detailed geology of the construction area was uncertain. The soil in the marked area was complex and had been chunked up with different compositions, so the drilling was monitored closely. Since Bertha was also one of a kind, navigating it was also uncertain. However, the operating engineers were determined to figure out and learn whatever they did not know on the job. In December, 5 months after the machine's launch into the Earth, Bertha encountered a catastrophic failure that almost ended the whole tunnel program. The gigantic tunnel boring machine hit a steel pipe and shut itself down after digging 1,083 feet through the ground. An inspection engineer had allegedly left the steel pipe by mistake while measuring the groundwater. 3 days after the incident, things went from bad to worse. The rubber seals around the main bearing failed, and grit got into the workings, damaging important parts of the machine, which began to overheat. All efforts by those on site to try to get it to work again failed, and 2 months later, Bertha was still trapped 120 feet underground with no way out. When nothing could be done by the field engineers, Hitachi, the manufacturer, concluded that the only way to repair Bertha was to dig it out and partly dismantle it. After months of messy legal proceedings over the financing of the repair project, arguments, and sample inspections, the repair was finally completed in December of 2015. Just a few days before Christmas, Bertha started digging forward again. The engineers heaved a sigh of relief, but the worst was yet to come. A year after another round of digging, Bertha dug through a layer of stiff clay mixed with sand and gravel at about 120 to 150 feet under the viaduct, causing a sinkhole to open 30 meters behind the tunnel boring machine. Bertha was shut down again for 6 weeks while the engineers filled the sinkhole. When it got back up 3 months later, Bertha was ready to roll. 200 feet deep, the boring machine dug through the city for 11 months without any negative issues. Then, after a final 6-inch course correction in March of 2017, Bertha was ready to fulfill its purpose. On the 4th of April, the gigantic tunnel boring machine punched through the concrete plug at the reception pit built for it, sending clouds of dust as the media watched. While Bertha made history, it met a tragic end. After the job, the engineers began dismantling each part of the giant tunnel boring machine into smaller pieces weighing about 20 tons so they could be taken away by road and restructured to build other infrastructure. While Bertha was historic for the United States and the world, it was not the only giant tunnel boring machine manufactured. The United States had another gigantic secret they tried to keep from the world. The mysterious tunnel borer that found artifacts. After Bertha, the United States was determined to do something better regarding tunnel construction, so they quickly funded another project. However, this time was secretive. The Chesapeake Bay Bridge Tunnel project started in 2017 in Virginia, just after the end of Bertha. However, it faced a lot of obstacles. The project was poised for a 5-year timeline, which means it was projected to finish in 2022. Still, several delays added another 5 years to its completion, far from what anyone could have imagined. After several delays from toll revenue, the United States introduced a giant tunnel boring machine called Chesapeake, which began mining the tunnel on February 2023. Chesapeake had only mined about 750 feet when workers spotted large pieces of steel on a conveyor belt that carries muck from the tunnel to the bay's surface. Upon further investigation, the engineers discovered that these pieces of steel were artifacts, possibly from a ship more than 50 years ago. One piece was engraved by W.L. Byers & Co., a company based in Sunderland, England, that produced anchors from the 1860s to about the 1950s. Nobody knows how the anchor got buried or to which ship it belonged. The British anchor was very common, weighing about 3.5 to 5 tons, but the Chesapeake ground it while tunneling. The engineers shut Chesapeake down to investigate the delay in their work. After investigation, they excavated and replaced the damaged parts of Chesapeake caused by the anchor. The grinding caused a lot of damage to Chesapeake's cutter head. 389 of the 442 tools, such as discs and scrapers, on the cutter head had to be replaced. For more than 6 months, the site engineers worked on repairing the damaged part and excavating the tunnel. For an additional 3 months after replacement, the construction crew worked on getting Chesapeake's cutter head back to working condition. The head was about 300 feet long. Although the anchor obstruction added 241 days to the project, Chesapeake returned to work, tunneling about 50 feet a day and having bored about 1,600 feet total, up to 25% of the planned 6,400 feet. The giant tunnel boring machine is expected to finish the job in late 2027. Chesapeake and Bertha are great, but not the only tunnel boring machines digging the earth. There are many types of tunnel boring machines, even with more sophistication. However, to understand each type, you must understand how they generally operate. How tunnel boring works. Tunnel boring is a mechanical drilling operation poised to dig full underground tunnels. As simple as it sounds, tunnel boring is more complex than an individual would assume. A tunnel boring machine usually weighs over 6,000 tons and is about 150 meters long. Since a tunnel borer cannot make a sharp turn because of its size, it performs the excavation process with its rotating head, also known as a cutter head, which makes a hole in the ground by using a motor with a hydraulic or electric system. Depending on the tunnel characteristics, the cutter head can be made of various materials. The machine creates a pushing force that ensures the rotating head continues drilling. Behind the tunnel boring machine is a platform on rails called lagging equipment, or buck-up, where other pieces of work equipment, like the transformers and fans, are located. It also creates a smooth means of excavation. After the excavation, the tunnel boring machine stops, and the rings are installed in the tunnel structure to keep it steady as the machine moves. TBMs are not the only mega construction machines available. They are just a fraction of the largest construction machines ever produced. Belaz 75710. The world's most enormous dump truck, Belaz 75710, is worth $7 million. This dump truck comes in different sizes, with one weighing 90 tons and another weighing 130 tons. It can carry 450 tons and handle up to 500 tons with an overload, which earned it a Guinness World Record. It also holds a second Guinness World Record for being the largest car by cubic capacity, 645 cubic meters. Its length is 20 meters, its width is 10 meters, and its height is over 8 meters. When overloaded, its total weight is 850 tons, equal to 2 giant passenger planes, the Airbus A380. When this dump truck needs to be transported to a job site, it's too big to be carried by road. Instead, it's taken apart and transported on 20 railway platforms, which means it takes up an entire train. This truck has two 16-cylinder engines, each producing 2,300 horsepower for a total of 4,600 horsepower. Each engine has about 76 liters, making the total capacity over 152 liters, 100 times larger than a mid-range car engine. The engine has a torque of nearly 10,000 nanometers. For comparison, a Hilux has around 500 nanometers, about 20 times more, enabling it to drive 2 generators. Those generators produce 3.5 thousand kilowatts of electricity. This vehicle could power 1,000 apartments if a small apartment needs about 3.5 kilowatts. The Belaz 75710 has 4 wheels, each powered by its own electric motor, with each motor having a power output of 1,600 horsepower. So, the Belaz is an electric vehicle because 4 electric motors drive it. The generators provide electricity to all 2 axles, driving all 8 wheels. Each of the 8 tires weighs almost 6 tons, and one tire costs between $50,000 and $90,000. This cost is equivalent to 2 to 4 economy-class cars. Each tire has a 4-meter diameter and is inflated to 7 atmospheres. If such a tire exploded, it would create a pit like 3 grenades had gone off. The fuel tank holds 2,800 liters, 55 times more than a Hilux. The huge Belaz truck drives about 100,000 kilometers a year and can be used for 10 to 12 years. Over its lifetime, it covered more than 1 million kilometers. It has 8 air filters that need frequent changing because the truck operates in dusty quarries. The Belaz was first introduced to the world in 2012. 5 manufacturers, including Belaz, make this type of large machine. The truck's top speed is 64 kilometers per hour. Its small cabin features 2 seats, an automatic transmission, 2 brake pedals, 1 accelerator pedal, and a cooling system. While operating, one of its engines runs at 800 revolutions per minute. LeTourneau L-2350. The next colossal machine is the largest front-end loader in the world, the LeTourneau L-2350. Made in Longview, Texas by the LeTourneau Company, This enormous loader moves minerals like gold, coal, copper ore, and other materials into bigger trucks. It weighs more than a Boeing 737, is about 2 stories tall, and can lift the weight of 40 cars above its head. The loader has a 50 cubic yard rock bucket that can lift 80 tons. To be more practical, 53 cubic yards is about the same as 5 regular dump trucks you see on the road. Front-end loaders are relatively new compared to other excavators. Although the LeTourneau company has a long history of making loaders, the L-2350 is their first model off the assembly line. Nearby, they have a test site where they put the machine through various tests. The LeTourneau L-2350 was designed because more giant trucks need bigger loaders. As dump trucks grew, engineers worked for 2 years to build a loader that could lift 50% more than the previous model. They even teamed up with Firestone to create the world's largest tires. These tires are 13 feet tall, over 5 feet wide, and are the biggest rubber pieces seen. LeTourneau makes many parts for the L-2350 at their Longview plant, and they even run a steel mill there. The L-2350's frame includes a radiator with a 150-gallon coolant capacity. It has a massive 16-cylinder diesel engine, turbocharged and after-cooled, producing about 2,300 horsepower. When operating, it burns about 50 gallons of fuel per hour. The diesel engine powers a generator, which supplies electricity to 4 electric motors that move the loader. Huge 16-inch hydraulic cylinders lift the big bucket, which can scoop up enough material to fill an Olympic-sized swimming pool in just a few scoops. Caterpillar 6090 FS. The Caterpillar 6090 is one of the most remarkable machines on Earth, weighing an astonishing 1,100 tons, equivalent to stacking over 1,000 mid-sized cars. Its immense size and weight highlight the exceptional engineering and design involved. Powered by a robust 793 horsepower engine, the Caterpillar 6090 can dig up to 122 feet deep and move up to 99,200 cubic yards of material daily, equivalent to excavating a football field over 100 feet deep in just one day. This incredible capacity is ideal for large-scale projects like bridge construction, high-rise buildings, and mining. Equipped with advanced technology such as GPS, 3D modeling, and automated controls, the 6090 can dig with precision and efficiency, speeding up work and reducing fuel consumption and costs. Sensors and cameras give the operator a comprehensive view of the digging process, allowing for real-time adjustments. These high-tech features make the 6090 invaluable for any construction or mining job. The machine also boasts a user-friendly control system, ensuring ease of operation. The operator's cab is designed for optimal visibility and comfort, minimizing fatigue and enhancing handling. Maintenance is straightforward, with a central lubrication system for easy greasing of moving parts and numerous access points for quick servicing. Beyond digging, the versatile Caterpillar 6090 is suitable for mining, construction, and demolition tasks. Its massive size and power make it perfect for large-scale projects, and it's equipped with various safety features, including emergency shut-off switches, fire suppression systems, and a rollover protective structure. The advanced technology of the 6090 ensures precise and efficient digging, reducing fuel consumption and overall costs. Over time, it can save companies significant money. Designed with environmental considerations, the machine includes emission reduction technology to minimize its environmental impact. The centralized lubrication system reduces oil leaks and spills, contributing to its eco-friendliness. The Caterpillar 6090's size, power, and advanced technology enable it to perform tasks impossible for smaller machines, all while maintaining precision and efficiency. Liebherr LR 300. The LR 300 crawler crane boasts a 3,000-ton lifting capacity and has successfully lifted a 3,370-ton test weight at its Ehingen factory in Germany, claiming the title of the world's strongest conventional crawler crane. Designed to lift its maximum load to a 12-meter radius, the 1300 is ideal for applications such as power stations, particularly nuclear plants with large pre-assembled modules, and refinery vessels where columns can weigh up to 1,500 tons and reach 100 meters in height. Each crawler stands over 3.5 meters tall and weighs over 200 tons. The hook block alone weighs 111 tons. The crane's maximum system length is 246 meters, achieved with a 20-meter main boom and a 26-meter luffing jib. 4 boom configurations can be combined: light, medium-heavy, heavy, and super-heavy. According to the manufacturer, the LR11300 is unique for operating without derrick ballast, thanks to its in-house produced slew ring. When used with a derrick, it features an adjustable suspended ballast system similar to the LR1350, which can be guided from a 20 to 30 meter ballast radius. A ballast trailer system is also available, combining the standard suspended ballast setup with a heavy lift modular trailer. For transport, the maximum component weight is 70 tons. Fully equipped with 400 tons of superstructure ballast and 1,500 tons of derrick ballast, the LR300 weighs 3,500 tons. Most components are under 3.6 meters tall and 4 meters wide. The crawler frames, measuring over 3.5 meters tall, 20 meters long, and weighing around 210 tons, are transported after the 82-ton tracks are removed and dismantled. The 128-ton frame is split in half and moved by a low loader. The 4.5-meter diameter slewing ring is transported diagonally to stay within a 4-meter width. To facilitate transport, the concrete ballast blocks are designed to match the dimensions of 20-foot containers. Big Muskie. This is the largest and most impressive walking dragline ever created, known as Big Muskie. It stands almost as tall as 22 stories and weighs a massive 10,000 tons. The Central Ohio Coal Company had a new project in the works. Their mine covered more than 110,000 acres of hilly terrain, and they needed a large machine to excavate the ground and extract coal. The Bucyrus Erie Company's factories were tasked with designing and constructing the components for Big Muskie, an incredibly massive machine. In 1969, this colossal machine was ready for operation after 3 years of work. It took 340 rail cars and 260 trucks to transport each component to the mine site, and it required 200,000 man-hours for assembly. It was constructed in around 2 years with a remarkable workforce. It cost $25 million in 1969, equivalent to about $107 million today. The bucket of Big Muskie had a capacity of 220 cubic yards, or 170 cubic meters, enough to hold 2 full-sized Greyhound buses side by side. In 1976, it was reported that this enormous machine removed 8,000 yards of overburden per operating hour for the coal company. Over its service life, it moved twice the amount of earth excavated during the original construction of the Panama Canal. Due to its immense size, this behemoth required substantial power to operate, equivalent to that needed for an entire town. 13,800 volts were supplied to the dragline through a trailing cable that powered 18 1,000 horsepower and 10 625 horsepower DC electric motors. This was comparable to the electricity usage of about 27,000 homes, making it extremely expensive to operate, costing tens of thousands of dollars per hour in electricity alone. As a result, the mining company had to make special arrangements with local Ohio power companies to handle the extra power load. They had to operate around the clock, with nighttime being the most cost-effective due to the lower kilowatt-hour rate than during the day. Notably, Big Muskie could move on its own using its massive hydraulic walker feet, traveling at a speed of about 0.1 mile per hour, usually covering less than a mile between digging positions. The machine served for 22 years, removing over 600 million cubic yards, or 460 million cubic meters, of overburden and uncovering over 20 million tons of coal. However, due to increasing electricity costs and opposition to strip mining operations in Ohio, the massive machine was retired in 1991. After lying dormant for 8 years, the state of Ohio began enforcing the Surface Mining Control and Reclamation Act in 1999, requiring all equipment to be removed from former strip mines for environmental remediation. The machine was eventually taken apart on-site and sold for scrap, with the scrap metal fetching $700,000. Only the massive bucket survived and is now displayed at Miners Memorial Park in Bristol, Ohio. The site where Big Muskie once operated was partially transformed into a wildlife park named The Wilds, which opened in 1994 and is home to various species of African, Asian, and North American wildlife. Komatsu D575A-3 superdozer. Let's talk about the Komatsu D575A-3 superdozer, the world's largest, most productive dozer by a factor of nearly 2. The Komatsu integrated design offers industry-leading productivity, reliability, and additional advanced standard features. Hydraulics, powertrains, frames, and all other major components are engineered and manufactured by Komatsu. Its engine is worth 858 kilowatts, 1,150 Hewlett-Packard turbocharged. The after-cooled engine provides plenty of power. The large blade capacity is 90 cubic meters. The D575A-3 superdozer reduces operating costs to dollars per ton through high-dosing productivity. The large superdozer blade with low dosing resistance and an automatic lockup torque converter saves fuel and increases speed in power transmission efficiency on long pushes. Komatsu's new ergonomically designed control system, PCCS, creates an operating environment with complete operator control. The travel control joystick is ergonomically designed to give the operator a relaxed posture and superb fine control without operator fatigue. Transmission gear shifting is simply carried out with the thumb. Fully adjustable suspension seat and travel control console for improved rear visibility during the return part of the cycle. The operator can adjust the seat 15 degrees to the right. The transmission and steering controls move with the seat for the best operator comfort. The travel control console also has adjustments for aft and height, with an independently adjustable armrest. Each D575A-3 operator can adjust control positions to his individual preference. The engine revolution is controlled by an electric signal, providing ease of operation and reducing problems caused by linkage joint seizures. The blade control joystick uses proportional pressure control, a PPC valve, and a palm command joystick, similar to the travel control joystick. Combined with the highly reliable Komatsu hydraulic system, PPC control enables superb fine control. The D575A-3 superdozer uses a newly designed powertrain electronic control system. The controller registers the number of operator control movements of the lever, the operation of switches, and machine condition signals from each sensor. It calculates to accurately control the torque converter, transmission, steering clutches, and brakes for optimized machine operation. The controller automatically adjusts each clutch engagement depending on travel conditions, such as gear speed, revolution, and shifting pattern. This provides no shock, smooth clutch engagement, improved component reliability, expansion of component life, and operator riding comfort. The large tinted glass windows provide a panoramic view of the work area. An air filter and higher internal pressure prevent dust from entering the cab. The constant machine condition check helps prevent severe problems and lets the operator concentrate on the controls. When an error occurs during operation, the user code and service meter are displayed alternately. When a high-importance user code is displayed, a caution lamp lights up, and a warning buzzer sounds to prevent the development of serious problems. The fuel-efficient Komatsu engine and the heavy machine weight make the D575A-3 superdozer a superior crawler dozer in dosing production. The engine is designed to surpass the Environmental Protection Agency and California Air Resources Board regulations and features direct fuel injection, a turbocharger, and an aftercooler to maximize fuel efficiency. The engine is mounted to the main frame with rubber cushions to minimize noise and vibration. For greater efficiency during long pushes, the lockup mode allows the system to engage the torque converter lockup clutch automatically. Locking up the torque converter transmits all the engine power directly to the transmission, increasing ground speed and thus achieving efficiencies equal to a direct drive. The system provides powerful traction, component durability, and operator comfort. Outstanding traction can be achieved because the shoes follow the ground's contour. The X-shaped bogie structure, a resilient equalized undercarriage, performs independent seesaw movements. Rubber shock absorbers are mounted on the X-shaped bogies to decrease vibration and shock. The bogies and rubber cushions provide different absorption characteristics depending on the ground surface. The remote electric unit is a conventional rigid undercarriage when the machine travels flat ground. The REU maximizes the suspension effect when the machine travels on uneven ground. The standard equipment includes a function for selecting travel speed presets, allowing the operator to choose from 3 preset patterns for fore and aft travel speeds: F1, R2, F2, and manual shift. If the F1, R2, or F2, R2 preset pattern is selected and the travel control joystick is moved forward or rearward, the machine will automatically travel at the F1, R2, or F2, R2 speed. This feature reduces operating hours and the time the operator shifts gears during repeated round-trip operations. The auto shift-down function controller monitors engine speed, travel gear, and travel speed. When a load is applied and the machine's travel speed is reduced, the controller automatically shifts to the optimal gear speed to ensure high fuel efficiency. This function allows for comfortable operation without manual downshifting, ultimately increasing productivity. Bagger 288. Bagger 288 is a bucket wheel excavator or mobile strip mining equipment manufactured by Krupp in Germany for the Rheinbraun Energy and Mining Corporation for $100 million. Bagger 288 was the world's biggest land vehicle when it finished in 1978, surpassing NASA's crawler transporter, which carried the Space Shuttle and the Apollo Saturn V launch vehicle. It is 45,000 tons heavy, with a height of 95 meters, 311 feet, and a length of 215.5 meters and 705 feet. The machine took 10 years to develop, build, and assemble. This German mining equipment is one of the world's biggest land vehicles, standing taller than the Statue of Liberty and weighing more than the Eiffel Tower. A bucket wheel excavator like this one is used to cut out an entire town. In the open-pit mines of the Western world, these diggers are employed. The Bagger 288 excavator can move 8.5 million cubic feet of soil each day with its spinning wheel of buckets. The Bagger 288 was designed to remove overburden from the Tagebau-Hambach coal mine in Germany before mining could begin. It can excavate the equivalent of a soccer field to a depth of 30 meters and 98 feet or 265,000 tons of brown coal, often known as lignite, in a single day. With its structure, 4 conveyor belts will collect overburdened soil and rock or lignite from buckets and transport the material at over 11 miles per hour. The belts are each 10.5 feet wide, making it easy to transport a smart car. The 13,000-ton bagger moves at a slow speed of 0.4 miles per hour using 8,600 square feet of tread. The excavator is powered by 5,600 feet of electrical lines, each of which is the diameter of a man's arm. The structure has 88,000 pounds of paint and comprises 248-foot-tall pylons and 7,218 feet of steel suspension cables. The bucket wheel's height equals a 7-story structure at 71 feet. Its 18 buckets weigh 7,700 pounds each when empty and can shovel 230 cubic feet of soil, enough to fill a cargo vehicle. 4-kilowatt motors power this massive bucket wheel excavator with a total driving power of 3,360 kilowatts, equivalent to or more than 30 small sedans. When the excavator travels over grass or soil, it leaves traces no deeper than a human footprint. Bagger 288 travels at a speed of 10 meters per minute and needs at least 3 weeks to complete a 22-kilometer journey. The machine has also crossed rivers, but this required extensive preparation. It takes at least 70 people to make way for the machine, and the last time it was moved across a river, it cost about $10 million. While the machine doesn't require mobility using treads during mining, it was more cost-effective to transport it on Caterpillar treads rather than disassembling and reassembling it at its destination. However, it is now owned and managed by RWE AG, a large energy company, and it is part of a fleet of 1958-built vehicles of the same size. No other earth diggers can move mountains like the RWE Bagger 288. Thanks for watching. See you in the next video.